Look at this. This and this. Now tell me, what do they all have in common? It's not just that they're feats of engineering, it's about the method. All of these places only exist because of dredging, a process that carves out the seabed and redistributes sediment beneath the waves. Dredging enables global maritime trade and, impossibly, for cities to grow from the sea. So how do we do it safely? At NexSens, we've supported thousands of projects, including dredging, with environmental monitoring systems. Follow along as we configure this dredge turbidity monitoring system. Dredging is commonly used to maintain or deepen navigational channels. For ports, this is necessary to enable ever larger vessels to dock. But it can also be used for remediation, where toxic sediment is removed and then capped with new, unpolluted sediment. Dredging has a major impact on the aquatic environment because suspended sediment can impact water quality and marine life, especially benthic species, making monitoring particularly important. So how do we measure its impact? Usually, turbidity. That's a measure of the cloudiness caused by suspended particles in the water column, is compared inside and outside of the dredging site in areas separated by a curtain. Buoys are the most common and effective way of getting these measurements. The buoy outside the curtain or dredging area provides the most important data because it tells operators how and how much their activity is impacting the environment outside of the intended area. If the turbidity reaches a certain level outside of the site, operation should pause to limit the transport of sediment. When configuring a dredge turbidity monitoring system, the XB-200 buoy offers the ideal platform for real-time measurement in nearshore environments. With a 30-inch diameter, the XB-200 is large enough to be visible to equipment operators and shipping traffic. At just under 70 pounds or 30 kilograms, it can be easily moved as needed during dredging operations. The XB-200 is solar-powered with 3 onboard 15-watt solar panels. And with over 250 pounds of net buoyancy, this buoy can support various topside and subsurface measurement instruments. Real-time data and alerts are essential to informed operations, so we'll go for the NexSens X3 data logger. There are multiple telemetry options available, but since our system will be near shore, we'll go for the cellular option. Let's move on to sensors and accessories. An LED beacon helps ensure the buoy is visible to maritime traffic at night and is a regulatory requirement in navigable areas. For subsurface sensors, we'll go for the NexSens NX260 turbidity sensor. Designed for reliability even during long-term deployments, this low-power sensor features a built-in wiper, titanium body, and integrates seamlessly with the NexSens data logger, where automatic detection makes setup as straightforward as plug and play. The sensor's large range of 0 to 1000 FNU ensures that conditions are accurately reported in both clear and turbid waters. We'll use a CM600 to secure the sensor to the buoy cage. If you're interested in getting even more data on the causes and impacts of turbidity, you could scale up to a larger buoy that's big enough to support a weather station, current profiler, and other water quality sensors. In lower traffic environments where visibility and the above water profile of the buoy aren't a concern, you could also scale down the system to a smaller buoy, but be sure to check project requirements and power budget, as the battery life may limit the frequency of data transmissions. For today though, we'll go with the XB-200, since it offers more potential to scale up instrumentation in the future. A minimum ballast weight of 15 pounds is recommended for the XB-200, and we'll need a chain and an anchor for mooring. Most buoys are deployed with either a catenary or inverted catenary, that's an S-shape mooring, depending on depth. But please confirm moorings with a marine engineer. For software, WQData Live is the online platform where we'll be able to view and export data, send remote commands, set alerts, and more. There are different tiers available in WQData Live to support varying requirements. As we want to be able to set comprehensive alerts and seamlessly share our data publicly, we'll go for the professional option. And that's it. Our dredge turbidity monitoring system is configured. With hundreds of easily integrated combinations and a plug-and-play system, with NexSens, it's never been easier to configure and deploy a custom environmental monitoring solution. Contact one of our experts today and start configuring your environmental monitoring system, or visit nexsens.com for more information. NexSens. Better data. It's never been easier.